This is Math 6, Lesson 3-5, Solving Addition Equations. Inverse operations are operations that undo each other. For example, closing the door undoes opening the door. Turning off the lights undoes turning on the lights. Addition undoes subtraction. Subtraction undoes addition. Multiplication undoes division. Division undoes multiplication. We will be using inverse operations to solve equations today. If we have addition equations, such as w plus 4.3 equals 9.1, if we want to solve this equation, we must keep it balanced. A balance is much like a little teeter-totter. If I have a teeter-totter and it has a fulcrum in the middle, and I put 5 pounds over here, to keep it balanced, I have to put 5 pounds over here. If I put more weight on this side here on the right, eventually the teeter-totter will get unbalanced, and instead of being flat like that, it'll end up being crooked like this. Because if I have 10 pounds on this side and 1 pound on this side, the one side that has the 10 pounds is going to be much heavier, and it'll make the teeter-totter unbalanced. When we solve equations in math, we want to keep them balanced. So if I have an equation, w plus 4.3 equals 9.1, there are two sides to every equation. The equal sign divides the two sides. So right here, if I was to draw a little squiggly line down through my equal sign, I have the left side of my equation, which says w plus 4.3, and the right side of my equation, which says 9.1. In order to keep these sides balanced, I need to have the variable all by itself. W is a loner. He does not like neighbors and friends. He likes to be all by himself. So we look at what was done to W and we notice that 4.3 was added to W. So we must eliminate the addition of 4.3 by undoing that. How do we undo that? We subtract 4.3. If we subtract 4.3 from one side of the equation, we must subtract 4.3 from the other side of the equation, thus keeping the teeter-totter balanced. By doing this, if we do this, 4.3 minus 4.3 cancels out. That becomes 0, or it just goes away, leaving us with W on the left side of the equation. W is now much happier because W doesn't like any neighbors, so he's all by himself now, and now all we have to do is take 9.1 and subtract 4.3. And if we do that, we get 4.8. So W equals 4.8. We can check every one of our equations to see if we are right or wrong. To check an equation, all you simply must do is plug in the value for your variable and see if it makes a true statement. So if I plug in 4.8 into this equation, I'm asking myself, I'm going to check it right here, is 4.8 plus 4.3, does that indeed equal 9.1? Well, let's find out. I'm going to write it underneath here so that I can actually add it. 8, 3 is 11, 4 and 4 is 8 plus 9.1 does indeed equal 9.1, so this does check. Every single equation can be checked. Once we have determined what our final answer is, it's always nice if you box it or circle your final answer so that people can see your work. Notice how I did my work vertically down the page. That's how mathematicians solve equations. Not across the page, but down the page. If we're looking at question number 2, h plus 9 equals 14. To get h all by his little lonesome, because here's there's my fence dividing one side of the equation from the other, that's the equal sign. 9 is added to h. To get my equations balanced, I need to subtract 9. So I'm going to subtract 9 from both sides. These 9's will cancel out, leaving me with h. 14 minus 9 is 5. So my answer is h equals 5. And again, I will check this to see if I am right. It says h5 plus 9. Does that equal 14? 9 plus 5 does indeed equal 14. 14 equals 14, so this definitely checks. Now, when you solve problems using an equation, drawing a diagram can be very, very helpful. This diagram I've drawn below indicates that the whole is equal to the sum of the parts, which kind of makes sense. Your whole equals part plus part. So let's take a look at a word problem here for a moment. A cat has gained 1.8 pounds in a year. It now weighs 11.6 pounds. Write and solve an equation to find out how much it weighed 1 year ago and check your solution. So, what we can do is we can kind of set up this whole part thing by drawing a little picture here. Okay. All I do is draw a big giant rectangle, split it down the center horizontally, and then split the bottom box vertically. Okay. I know that the cat's weight now has got to equal what it weighed before plus how much it's gained. So weight before and then weight gained. Okay, I know that. That makes sense. The weight last year and the weight it's gained has got to be the cat's weight now. So the next thing I need to do is, the question here is asking me, okay, how much it weighed 1 year ago. That's the question that this statement is asking. It's saying it wants to know how much did my cat weigh last year. Okay? So what I'm going to do is I'm going to let my variable equal what I highlighted. The question that it's asking you is normally defined by your variable. So my variable I'm going to let be W, and that's going to be cat's weight 1 year ago. So the cat's weight last year is W. The cat's weight now is 11.6 pounds. They told me that. So if I follow my diagram, it says, in my diagram, it says my cat's weight now should equal the weight before plus the weight gained. So the weight now equals the weight before plus the weight gained. So, terrible E. The weight now is 11.6 pounds. That needs to equal the cat's weight before, which is W, that's what I defined it as, plus how much weight it has gained, which was 1.8 pounds. So there's my equation. 11.6 equals W plus 1.8. I can take any word problem and write it into an equation if I think it through clearly. So here I have 11.6 equals W plus 1.8. To solve for this, I need to get W by itself. Notice the two equations we had before this, the variable was on the left-hand side, now the variable's on the right-hand side. It doesn't matter which side the variable is on. Okay? W still wants to be by itself. What did they do to W? They added 1.8 to it. So what do I need to do? I need to subtract 1.8. Make sure to line up your decimal points. These will cancel. Okay, leaving me with W on the right-hand side. If I take 11.6 and I subtract 1.8 from it, okay, I get 9.8. This is a word problem, and all word problems are always written in a complete sentence. And W, if you remember, stood for the cat's weight last year. So the cat weighed 9.8 pounds last year. So there you have. The cat weighed 9.8 pounds last year. Let's look at another word problem. Today, Anna discovered that she is 4 inches taller than she was last year at this time. Anna's height today is 51 inches. What was Anna's height last year at this time? Now you might be saying, but Mrs. Sheelan, I could solve this so much faster if I just did a basic math subtraction problem. I'm not asking you to do a math subtraction problem. I'm trying to get you to start thinking like a mathematician and learn how to solve things algebraically through equations, so that when you get harder problems, you will understand how to do those. If you can do the easier ones and set them up properly, then setting up the more difficult problems will be just as easy. So if I think of this, remember, if I think again as the whole equals the part plus the part, Okay. That would be Anna's height now. Should equal her height last year plus how much she's grown. Okay, so Anna's height now should equal what she was last year plus how much she's grown now. Okay. Since the question was asked, if you remember, the question was asked, what was her height last year? That's what it wants us to find. I'm going to let my variable equal last year's height. So I'm going to say h equals last year's height. Okay. It says Anna's height now. Oh, I didn't spell that right, did I? Let's fix that. H-E-I-G-H-T. There we go. Anna's height now is equal to last year's height plus how much she's grown. So Anna's height now, her height today is 51 inches. So 51, her height now equals last year's height, which I don't know what that is, plus how much she's grown, which I do know what that is. So there's my equation. These equations are not difficult, but they need to be done in the order in which the sentence gave them to you. The sentence said that her height today is equal to last year's height plus how much she's grown, so we need to write it that way. So to solve this, to get h by itself, we need to subtract 4. Okay, and positive 4 and negative 4 cancels out, leaving me with h, and 51 minus 4 is 47. So Anna's height last year was 47 inches. Solving word problems is all based upon understanding how to get your variable all by itself. Okay? And that basically, what we just did is what's called the subtraction property of equality, which means if you subtract the same value from each side of an equation, the two sides remain equal. For example, if I have 2 times 3 equals 6, 2 times 3 minus 4 is the same as saying 6 minus 4. Or if A equals B, then A minus C equals B minus C. As long as you subtract the same thing from both sides of your equation, it keeps your equation balanced.